Welcome dear students to another very important topic of the organic chemistry, and that is the nucleophilic substitution reactions of the alkyl halides, abbreviated as SN reactions. These reactions are defined as the reactions in which a stronger nucleophile replaces halide ion from alkyl halide, and this halide ion acts as a weaker nucleophile. So basically, a stronger nucleophile replaces a weaker nucleophile, and these are the nucleophilic substitution reactions. In this case, the stronger nucleophile specifically replaces the halide ions from the alkyl halides. The example of nucleophilic substitution reaction is the hydrolysis of alkyl halides in the presence of a strong base like aqueous NaOH. Now, in this reaction, the alkyl halide molecule will act as substrate, mean it will be the molecule on which the attacking nucleophile will attack. And the attacking nucleophile, our attacking group is OH negative here, that will attack on the substrate and it will replace the weaker nucleophile which is already present in the substrate, and that is the halide ion. As the halide ion will leave the molecule of the alkyl halide, so they will be called as the leaving group. And now the X negative is replaced by OH negative, and you will get a product that will be an alcohol. So during this reaction, alkyl halide is changed to alcohol by the replacement of the X negative with OH negative. Now this reaction can proceed by two mechanisms. The first one is the SN2 reaction, which is called as nucleophilic substitution bimolecular reaction. My dear students, the SN2 reaction is a single step reaction in which the reactants are first changed into a transition state, and then the transition state is changed to the products. These three are called as the reaction coordinates. These three are called as reaction coordinates. Reaction coordinates means the reactants, transition state, and the product. So SN2 reaction, the first point is that it is a single step reaction in which the reactants are changed to products through a transition state. Now my dear students, in case of SN2 reactions, we have taken an example of methyl bromide here, which is a primary alkyl halide. It will act as substrate, and the attacking group OH negative will attack on the alpha carbon of the alkyl halides. This one is the alpha carbon. When the OH negative attacks the alpha carbon, then alpha carbon breaks its bond with the halide or the bromide. Now what will happen? First of all, a transition state is formed in which these two dotted lines are showing that the bond with bromine is not completely cleaved and the bond with OH is not completely formed. Rather, the two processes are simultaneously going on: formation of bond with OH and breakage of bond with the bromine. Now, in this case, my dear students, the OH is giving its two electrons to form a bond with the carbon, and the bromine is taking away the two bonding electrons to break its bond with the carbon. The hydrogens attached to the carbon, they are present in one plane, and OH and Br, they are perpendicular to the plane containing the carbon and hydrogen bonds, and the energy which is required to break this bond is provided by the energy which will be released during the formation of this bond. Now finally, the CBr bond will be broken down, and bromine, after taking both bonding electrons, that will leave the molecule of the alkyl halide, and OH will attach to the carbon, and you will get product, that is the methanol here. My dear students, it is a single step reaction. Now the second point is that if it is a single step reaction, it means it is the rate determining step. This single step will be the slowest step, and that will be the rate determining step. Now how many molecules are taking part in the rate determining step? There are two molecules. One is the attacking group and second one is the methyl bromide. And those reactions in which two molecules take part in the slowest step or rate determining step, they are called as the bimolecular reactions. So that is why this reaction will be called as the bimolecular reaction, because there are two molecules which are taking part in the slowest step of the reaction, in the rate determining step of the reaction. Now, my dear students, how we can write down its rate law? So its rate law will be R is equal to K, attacking group and substrate. The attacking group is OH negative and the substrate is methyl bromide. It means that the rate of reaction in case of SN2 reactions depends upon the concentration of both attacking group as well as the concentration of the substrate. If you will double the concentration of attacking group, the rate of reaction will also double. If you will double the concentration of substrate, keeping the concentration of attacking group constant, then the rate of reaction will also double. And if you will double concentration of both these attacking group and substrate, obviously the rate of reaction will be increased 4 times. It means the exponent, that is 1, this one is also 1. So the order of reaction, that will be 2. Means SN2 reaction is a bimolecular reaction because two molecules are taking part in the slow step, and SN2 reaction is a second order reaction in which the rate of reaction depends upon the concentration of both attacking group as well as the substrate. Next point, my dear students, in case of this SN2 reaction, this carbon of the substrate, this is sp3 hybridized. When it moves to transition state, this one is sp2 hybridized with only 3 bonds. And now the product, again the alpha carbon is sp3 hybridized with all 4 bonds, which are all sigma bonds. So the next point is, in SN2 reactions, the hybridization changes from sp3 to sp2 to sp3. This is the change in the hybridization. Now, my dear students, the next point is SN2 reactions are shown by the primary alkyl halides. Mean primary alkyl halides, they favor the SN2 reactions. Why they favor, we will discuss this point later on in this lecture. So SN2 reactions are given by primary alkyl halides, or they are most favorable with the primary alkyl halides. Next point is that in SN2, the attacking group attacks from the back side as compared to the side where the leaving group is attached. Why? Because OH negative is electron rich, and you know bromine with 3 lone pair of electrons, that will also be electron rich. So one electron rich species, when it faces the other electron rich species, naturally there will be forces of repulsion. So OH negative will not be able to attack from this side due to the repulsion with the bromine, which is itself an electron rich species. That's why the OH negative always attacks from the opposite side as compared to the attachment of the halide ion. Now, my dear students, because of this attack from the opposite side, now you can see that the configuration of the substrate and that of the product, they are inverted. Mean the position of hydrogens and the nucleophile, that is inverted in the product as compared to the substrate. This inversion is called as the Weldon inversion. This is called as Weldon inversion of configuration. And my dear students, there are 100% chances that there will be inversion of the configuration, because the attacking group always attacks from the back side. If the substrate is optically active and product is also optically active, then if the substrate will be dextrorotatory, the product will become levorotatory. And if the substrate will be levorotatory, the product will become dextrorotatory due to this inversion of the configuration. And this inversion of configuration is proved by the optical activity of the substrate and that of the product. So, my dear students, SN2 reactions are most favorable with primary, then secondary, and least favorable with the tertiary. Now let us revise SN2 reactions in 1 minute. These are the reactions which are single step reactions. These are the bimolecular reactions in which two molecules take part in the rate determining step. These are the second order reactions because the rate of reaction depends on the concentration of both attacking group and substrate. The hybridization changes from sp3 to sp2 to sp3, and then there are 100% chances of the inversion of configuration in SN2, which are proved by the optical activity of the substrate and product. And then all alkyl halides, they show SN2 reactions, but most favorable with the primary and least favorable with the tertiary. Now let us move to the second mechanism, that is the SN1 reaction, which are the unimolecular reaction. Now, my dear student, SN1 reaction is a two-step mechanism in which the first step is the reversible step as well as the slow step. As this is the slow step, so it will be rate determining step. In this first step, the alkyl halide in the presence of any polar solvent gets ionized and it forms a carbocation, and the leaving group leaves the substrate, the molecule. In the second step, which is the fast one, in this second step, now the attacking group attacks the positively charged carbon as it is itself negatively charged. Now, the attacking group has equal chances to attack from any side to this positively charged carbon, because the attacking group can attack from any sides to this positively charged carbon. So there are chances that the two types of the products can form having different configuration from each other. There will be 50% chances of formation of this product if the attacking group attacks from this side, and there will be 50% chances of the formation of this product if the attacking group attacks from the other side. These two will be isomers of each other. They will be having same molecular formula, even their structural formula will be same, but overall configuration, the position of the atoms or groups in space, that will be different. Now, my dear students, it means first point is that SN1 is a two-step reaction. The first step is the slow and reversible, and that is the rate determining step. The second step is fast step. The second point is that in the rate determining step, only one molecule of the alkyl halide takes place. That's why they are called as the unimolecular reactions, because there is only one molecule which is taking part in the rate determining step. How we can write down their rate law? Their rate law will be written as R is equal to K, and as only substrate is taking part, only the molecule of alkyl halide is taking part in the slow step, so the rate of reaction will only depend on the concentration of substrate, or you can say alkyl halide, and it will be independent of the concentration of the attacking group, because attacking group is not in the slow step. If you will double the concentration of the substrate, rate of reaction will double. You will increase it 3 times, rate of reaction will also be increased 3 times. But if you will keep on increasing the concentration of the attacking group, there will be no effect on the rate of the reactions. So you can say that these are basically the first order reactions. So SN1, they are unimolecular as well as they are the first order reactions. Now, my dear students, the next point is that in SN1 reactions, in the first step, the hybridization changes from sp3 to sp2, and we will consider only alpha carbon when we will be discussing the hybridization. So the hybridization of alpha carbon changes from sp3 to sp2, and in the second step it changes back from sp2 to sp3, because both these carbons, they are sp3 hybridized carbons. So in the first step, hybridization changes from sp3 to sp2. In the second step, again from sp2 to sp3, and only the hybridization state of the alpha carbon is considered. Now, my dear students, Next point is that in SN2 there were 100% chances of the inversion of configuration, but in case of the SN1 reaction, compare this product with this substrate, you will find that they have same configuration. So in this case, there will be 50% retention of configuration. And now compare this one with this. You will find the inversion of configuration. So there will be 50% chances of inversion of configuration. And if these two will be optically active, then one of them will be dextrorotatory and the other of them that will be the levorotatory. And as they will be present in equal quantity in the mixture, so if they will be optically active, then you will get a racemic mixture. So you will get a racemic mixture at the end. Now, my dear students, all alkyl halides they show SN1 reactions, but SN1 reactions are most favorable with tertiary alkyl halides, then secondary, and then primary. You can see that secondary in both cases, that is in the middle. It means the secondary alkyl halides they have equal opportunity, they have equal chances to show the SN1 and SN2 reaction. It depends upon the medium in which the secondary alkyl halides are present. If you will provide them polar solvent, then the secondary alkyl halides will be ionized and they will show SN1 reactions. But if you will provide them a non-polar medium, then they will not be ionized and they will show the SN2 mechanism. So it depends upon the environment you are providing to the secondary alkyl halides. As far as the primary are concerned, they show SN2 preferably and tertiary they show SN1 preferably. Why? Because in case of primary alkyl halides, with alpha carbon, small groups are attached. As the small groups are attached, so nucleophile will not face much hindrance, much steric hindrance when it will be attacking. So the attack of the nucleophile is possible even if the leaving group is attached with the alpha carbon. But in case of the tertiary alkyl halide, the bulkier groups are attached with the alpha carbon having very high steric hindrance. When the nucleophile will approach the molecule to attack, it will not find any space through which it can approach the alpha carbon as the bulkier groups will not provide any space. So it is necessary that in case of tertiary alkyl halides, first of all the leaving group must leave so that some space may be created for the attack of the attacking group. And then in the second step, the attacking group will be able to attack the alpha carbon or it will be able to reach the alpha carbon. This attacking group cannot reach this alpha carbon in the presence of all bulkier groups. So that's why the tertiary alkyl halides they will prefer SN1, the primary alkyl halides they will prefer SN2, and the secondary alkyl halides they equally prefer SN1 and SN2 depends upon the medium you are providing them. This was, my dear students, all about the SN1 and SN2 reactions. Whenever you are memorizing these two reactions, draw a line, make a table, and then write their points. It is two-step, it is one-step, it is shown preferably by primary, it is shown preferably by tertiary. So then you will be able to understand completely this topic and you will be able to memorize it easily. If you feel any problem in nucleophilic substitution reactions or any problem in overall chemistry, you can ask in the comment section. I will answer that. Take care.